Hey guys, I just wanted to walk through a quick circuit problem. Seems like a lot of you guys struggled with this on the quiz, so I wanted to put a video out there, that way you'd have something to refer to outside of class. So what we've got here is the exact math problem from the quiz, and I'm just going to go through it step by step. We're going to talk about the rules that are in place for solving these kind of problems. So the first thing I want to talk about is parallel versus series. So if you look at this, we can see that R2, R3, and R4 are in parallel in this circuit, and R1 is in series. And we need to know that because there are different laws that apply to series circuits as opposed to parallel circuits. So when you're going to solve a circuit problem that has a combination of both, we need to know which one's which so we know what formulas to apply. The first thing I want to look at is what we're given in this diagram. So the first thing we look at is we're given total voltage here. And I've made my little table down here like I tried to show you guys in class. I think that's the best way to kind of keep all your numbers straight and solve these problems. So the first one I've got is total voltage. I'm going to go ahead and type that in here because we're given that right in the diagram. We are also given the individual resistances for R1, 2, 3, and 4. So I'm going to go ahead and put those in as well. Alright, so based on the numbers that we have in this graph now, we should be able to calculate a few items. So the first thing I can look at is I've got all my resistors, so I've got what I need to calculate total resistance. Based on whether the resistors are in parallel or series, the formula changes. So I've got a couple of the formulas over here. In series, you just add the resistances up, and in parallel, you do the 1 over R1 plus 1 over R2 and take 1 over that number, and that gives you the total. So the first thing I want to do is figure out the three parallel resistors. We're going to figure out the resistance for those and make that an equivalent resistor so that we can add them to R1 and get total resistance. So we'll do the math over here, and I'll try to bring my little calculator app up on screen here. And let's just start with R2. So it's going to be 1 divided by 80 equals that. We're going to add that to 1 divided by 60. And we're going to add that to 1 divided by 80 again. And you come up with 0.04166. Now remember, we got to do 1 over this number. So our final number is going to be 1 divided by 0.04166. And that gives us right at 24. So I'm just going to kind of type that out of the way here so we don't remember it, so we don't forget it. R234 is 24 ohms. So if those three put together are 24 ohms and R1 is 68 ohms, we can add those two together to get us total resistance. 68 plus 24, total resistance is 92 ohms. So now we have total resistance and we have total voltage. Well, if you have two of any three of these, you can mathematically figure out what the third one is using Ohm's law over here. So I've got E total and I've got R total. So if you cover up the I, it's E divided by R. And that's going to give us current total for the entire circuit. 46 is our total voltage, divided by 92 is our total resistance, and you come out with 0.5. So our current in this circuit is half an amp, 0.5 of an amp. Okay, now this is where most people get hung up. You look at this and you don't see 2 of the 3 on any of the other boxes we need to figure out. So you look at it and go, well, I need 2 of the 3 to mathematically calculate them. Well, here's where you have to start applying these Kirchhoff's laws. So there's only 2. One for series circuits and one for parallel circuits. And I've paraphrased these a little bit, but in essence what they say is this. In a series circuit, voltage will change and current will not. In a parallel circuit, current is what changes and voltage does not. So let's start with the one that's in series. R1 is in series with Rs 2, 3, and 4. So R1 is in a series part of the circuit. In that part of the circuit, our voltage will change, but our current will not. Well, I know what system current is, and since current doesn't change in a series circuit, system current is what's going to be the current at R1. So current at component 1 is going to be whatever system is, 0.5 of an amp. Now I have 2 of the 3, and I can mathematically calculate for voltage. If I'm looking for E, it's I times R. Our I is 0.5. Our R is 68. And that gives us the voltage at component 1 as being 34. So what that actually means is that is a voltage drop at R1. So we have 46 volts going into R1. It's going to drop 34 there. So we have whatever's left coming out of R1 going to the rest of this circuit. 34 minus 46 is going to give us 12 volts. So after our voltage drop at R1, we're going to have 12 volts left coming out of it to go to all 3 parallel. Because in a parallel circuit, voltage does not change, but current does. If I've got 12 volts going in to the top of this parallel branch, I'm going to have 12 volts coming out of it. So I can go ahead and put 12 volts for each one of those. So 12, 12, and 12. Now I have what I need to mathematically calculate what does change in a parallel circuit, which is current. And that's going to be, we're looking for I, it's E divided by R, and that will give us the current split here. So think of it like liquid or hydraulics. When you have a half an amp coming in here, if this was a liter of water, the water all wouldn't go through R3. Some of it would go through R2, some of it would go through R4, some of it would go through R3. And how much of it would go through those is going to be based upon the amount of resistance that they will encounter along the way. That's what these resistance values are. The higher the resistance, the smaller the tube. Think of it like that, which means the less amount of current will go through that one. So anyway, if we have 5 amps, or 0.5 amps, I'm sorry, coming in, it's going to split 3 ways. Let's do the math. 12 volts divided by 80 for R2 gives us 0.15 of an amp there. Volts divided by 60 for R3 gives us 0.2 of an amp there. And then 12 volts divided by 80 for R4 gives us 0.15 of an amp there. And you'll know you did this step right if all 3 of those add up to system, which they do. 0.15 and 0.15 is 0.30. And 0.2 makes it 0.5. So your 0.5 of an amp that you had coming into the circuit splits 3 ways. And then down here at the bottom, when they all go back to ground, they all combine back to equal your system current.